In the second exercise, we find some special subsets of the real numbers. These are the intervals. We have interval A from 0 to positive infinity. It's an open interval. We have interval B, negative infinity to 3, also an open interval. And interval C, negative 2 to 1, closed at negative 2, open at 1. We are looking for the elements of this set, C union B intersection A complement, with respect to the real numbers. We are looking for the elements of this interval, and we will use the real number line for solving this exercise. First, let's draw a real number line. And it's ready. As you can see, my drawing skills are quite poor. But the important thing is, it's not a number line if there is no 0 on it, so I have my 0. It's not a number line if I don't show the direction of growth, which I have here. And the third one is a more tactical approach. Look for your points of interest. See, here I'm interested in negative 2, interested in 0, interested in 1, and interested in 3. So these points should be clearly visible on my number line. And if your number line fits this criteria, then it's an excellent number line. So let's draw these intervals. Interval A goes from 0 to positive infinity, and this is an open interval. So with open intervals, the interval's endpoint is marked with a ring or an empty dot. And we don't mark anything at the infinity part. I just assume that this red line goes on and on and on and on and on. So here we have interval A. Interval B will be blue. This is also an open interval. One of the ends is at negative infinity. The other one is at 3, open, so I draw an empty dot. And the third interval, C, is from negative 2 to positive 1. At negative 2, this interval is closed. It means that negative 2 is part of the interval, whereas 0 is not part of interval A and 3 is not part of interval B. So it is closed at negative 2, open at positive 1, and we've got this. Okay, let's break this expression down. So first we have B intersection A. This means every number which is in both A and B, which means in this case from 0 to 3, open interval. You can use a comma as a separator or a semicolon. I have used semicolons my entire life, so I have no plans of changing this right now. Here we have B intersection A. Now I need to find the complement of this interval with respect to the real numbers. Now if I want to read this out, it means that B intersection A means numbers which are greater than 0 and less than 3. So the complement of this means numbers that are less than or equal to 0 or greater than or equal to 3, which means this is the union of two intervals. One of the intervals is from negative infinity to 0, closed, and the other one is from 3 to positive infinity, closed at 3. By definition, if the endpoints are at negative or positive infinity, then those endpoints are open. So, writing it down, negative infinity to 0, closed at 0, union sign closed at 3 to positive infinity. Now we have to unite this interval with interval C. Graphically, it means that I add this part to the existing blue intervals. So I have a part coming from negative infinity to +1, and I have this other part starting from positive 3 to positive infinity. So this bottom green part is C union B intersect A's complement. So let's write it down. C union B intersect A's complement is negative infinity to positive 1 open interval, because this end is open, united with 3 to positive infinity, closed at 3, open at the infinity. And every other part of exercise 2 can be solved similarly.